Okay, so the noble gas core, noble gas notation. Last time we took notes about electron configurations, you asked about what if we have to write out a configuration for uranium or something that's way down and you have to write out that whole thing. That's where the noble gas notation comes in. You're going to be able to do a little shortcut where you put the preceding noble gas in brackets and then you continue on from that point. So what would that be? 4p2. That's germanium. The argon 4s2, 3d10, 4p2. So when you find germanium, you find the noble gas that comes before germanium would be argon. You put that in, germanium's number 32. Put argon in brackets, and then you start from argon. After argon, you would go to 4s2, 1, 2, and then after 4s, remember the first D sublevel is 3d, 3d10, and then 4p2. So you just have to look for the noble gas that comes before that element. So let's try that. We're going to write the complete configuration and noble gas notation for iron. I'm going to get a new page here. What color of ink should I use?
Brown.
Ooh, brown was first.
Yeah.
Although I don't, which brown? Those are the only two browns.
Oh, you don't have to do brown. I just
Well, you said brown.
do a good color.
Iron, Fe. Okay, so we want the complete configuration where we'd start all the way back at 1s, 2, and what comes after 1s? 2s, 2, and then what? 6, because we haven't gotten to iron yet. After 2p, we have 3p6. Okay. 3d6? Yep, 3d6. Okay, so that would be our full configuration, and then we want to do the noble gas configuration. Yes, they're using the fume hood, so they're going to be back there. We'll just, all it does is suck out the gas that's produced. They're going to be doing fingerprints, smoking fingerprints.
What living thing is
Forensics. A living thing?
that? Like if you
It doesn't create a vacuum. It's not a vacuum.
No, I know that, but sucking the gas out of like a mammal, you put a rat in it.
It'd be fine. It's not that, yeah. Yes, Remington.
Where do you get the 2 from in S2?
That's how many electrons are in that orbital, that filled that orbital, or that sublevel. So P can hold a maximum of 6 and it's full. And we use the periodic table, and the P block is from boron over to neon and down. And if you count across, there's 6. So you can just count that.
So it's going to be 6.
That's the maximum. Now, if you were doing nitrogen, you'd only count across 3 and be P3. You'd stop there. That's why the D, we stop at 6 instead of going to 10. Here. Okay, iron. What's the noble gas that comes before iron? Argon. So we put Ar in brackets. And then after Ar, we're down to potassium, and that would be 4s2, 3d6. So that would be our noble gas notation for iron. The electron-containing orbitals. So it's going to start asking questions about this. How many electron-containing orbitals are there in iron? We want to go through each of these and look at how many orbitals there are. So in the S sublevel, how many orbitals? I'm going to put a little 1 here just to mark it. S has 1. P has, and then here's 1, 3, 1. Now, for this one is not full, right? The 3D is not full. So I like to just check it. There's 5 possible orbitals, correct? And we have 6 electrons. We have 1, 2, 3, 4, 5, 6. So how many electron containing, how many of these orbitals have at least 1 electron? All 5 of them do. Yes.
Like when you're going past 57, do you drop into the
Yeah, we'll get to that. We'll do one like that. Yep. So we add these all up. 2 plus 3 is 5. 6 plus 3 is 9, 10, 15. So we have 15 electron-containing orbitals. And then I think the next question is, how many are completely filled? So all of them are except for these 4, correct? So we have 11. Completely filled. How many unpaired electrons are there? 4. And in which sublevel are the unpaired electrons located? 3D. Now, the unpaired electrons, those are what are going to be important in bonding. When we get to bonding next chapter, those are the electrons that are going to be involved in chemical bonds, are the unpaired electrons. They're either going to pair up by gaining electrons, or they're going to share with another atom and form covalent bonds. It could ask also how many empty orbitals are there? And this one, how many empty orbitals? There's 0. Sometimes if it would have been like 3d3, there would have been 2 empty orbitals. I think that's it. Do you guys have questions about that? Okay, let's see what we got next. Ooh, zirconium. How about you guys start going and writing the noble gas or the electron configuration? It says both the noble gas. Where is zirconium? Okay, number 40. So do both the full configuration and the noble gas configuration for zirconium, and then I'll start writing it out, and you can check yours against mine. You could start writing your answers for the questions as well.
You not see me doing this?
Okay, that's what the full should look like. And your noble gas should look
I did.
like that. And then it says, how many electron-containing orbitals are there? So now let's go through. We have, these are all full until we get to that 4D, so let's add all these up. Plus 1, plus 5, plus 3, plus 1. And then how many would be electron-containing here?
21.
2. We have 1, 2. It goes up, up. So I'm going to put a 2 here. So we have 1 plus 1, 2 plus 3 is 5, 6, 9, 10, 15, 18, 19, 20, 21. And how many are completely filled?
19.
19, because we counted 2 here, but they are not completely filled. So 19 are filled. How many lone electrons? No, there's just 2. Unpaired electrons. How many empty orbitals? Yeah. 3 empty. Okay. Let's make sure we do a problem. I don't know what's next. Oops. Oh, these are some review multiple choice. I'm going to just see what's after this. Otherwise, we'll pick a different one to go into the F. Oops. Yeah, so before we do this, let's do uranium. Okay, for uranium, you don't have to go and do the whole thing. Let's just do the noble gas configuration for uranium.
All right.
So uranium is in period 7. So the noble gas that comes before uranium would be radon. Oops, I don't know why I put an R there.
Good catch.
Thanks.
Rn. And what would come after radon?
7S2.
7s2. Okay, now I think your book will talk about shielding and the shielding effect, but we're not going to do that. We're just going to simplify it for now. And so if you do look on your calculator or some of the periodic tables over in my chart rack will have a little different electron configurations. I want you to do it this way. Okay. We aren't going to go into the shielding effect. So what would come after 7s2 is 6d1. Yep. Because we have actinium 89, but then it goes 89 to 104. So we need to go from 89 to 90 down, and that would be 5p or 5f. Sorry. Because the first F sublevel, the lanthanide series, it has to be 4F, and so the second, the actinide series is 5F. 5F, and then 3. Sometimes you'll see them written in order of main energy level, principal quantum number. So it'd basically be backwards, where 5s are first and then 6. Even sometimes when we had like 3D thrown in there, they'd rearrange it so the 3D would come before the P. You don't have to do that, but just in case you see that somewhere. Yes, Trey.
If it's like tungsten,
Yeah.
it goes over where.
Okay, let's do tungsten next. Let's do tungsten. So tungsten's number 74, so we have xenon. And then we would have what?
6s2.
6s2.
Do you go down into the F?
Well, you'd have 5d1, and then it would go to 4f, and you'd count all of them across would be 14.
What?
And then 5, we'd have to finish filling 5d1, 2, 3. So you could write it this way. Now there's a couple ways we can do this. We can write it this way, or you could add those together, and you could do 5d4. But then don't forget, some people when they do that, they count over 4, they forget the f. Don't forget to add the f in there. You still have the 4f14.
Just the last part.
So you can add those two together. Or when you count across, you'd go 1, 2, 3, 4, but don't forget to add the f in there, because you don't actually, like when you're counting across in the D, you don't actually go to the F, but don't forget to add the F in. What's it say for tungsten on your calculator? Evan, do you have it?
4F14, 5D4.
Oh, it does. Okay. But they put it in order of principal quantum number. So they put 4, 5, 6. some of them you'll notice it would be different. It might be like 6s1 5d5 instead. It's called the shielding effect, but we aren't going to do that. Any questions? Any other ones you want to try doing? I think so. We want to go through some of these. There's some multiple choice that I added in at the end. Do you want to go through some of those? Yeah. Okay. Orbital diagram for a ground state of oxygen. Which one would be the ground state of oxygen? Was it? Maybe something similar to it. Well, if it is the excited state, that means one of the electrons in the lower energy levels have just moved and jumped into a high energy level, right? Because that means electrons have gained energy. So maybe one of these electrons, well, which ones are right? A correct answer? D, row 4. So maybe this electron would have moved over here, and there would just be one electron here, and there'd be an extra one in here, because it has moved up an energy level. That's so excited. Okay, so oxygen, 1s2, 2s2, 2p4, right? Yeah. So we have 1s2, 2s2 for all of them, and then we need 4 here. Now this one has 4, but it needs to be 1, 1, 1, and then the 4th one. So this one would have to be the correct one. 3 and 2 are exactly the same, aren't they? Huh.
I was trying to figure it out because I watched the lecture, and then how does copper work? It's like you can have like one of them, doesn't have both of them in it, 4s or whatever.
What? Copper?
4s sublevel, it only has one copper.
That would be the shielding effect. We'll do 4s2, 3d9. Yeah. Where were you watching that? Oh, and you looked up the configuration? Yeah, that'd be the shielding effect. No. So just fill it how we would. If you go on to college chemistry, you might have to learn about that. We don't. We've never touched this in the chemistry class we do here, but other colleges might. No, don't have to do that here. Okay, what about this one? What element would this be?
Antimony.
Yep. Which would be which one? B. Right. Really, all you have to look at is this last one, right? As long as everything else is filled, just look at 5p3, go down to the 5th energy level across 3 in the p sublevel, and it's antimony.
Okay, when it says like Z equals 6, 5,
Mm-hmm.
what does the Z?
What is Z? What's Z stand for? Atomic number, yeah.
Oh, shut up.
It's all right. Did Josh know that?
Yeah, we talked about like a base here.
I wasn't thinking along those lines.
How many electrons are in the 3rd principal energy level of phosphorus? So find phosphorus, number 15. How many electrons are in the 3rd energy level of phosphorus?
3p3.
It is 5, yes. Why 5? So this would be your complete configuration, and we're looking at n equals 3 would be the 3rd energy level. These two sublevels. So how many electrons are in the 3s and 3p of phosphorus? There's 2 plus 3 is 5.
So if it would have said n equals 2, then you would have done the 2.
If it would have been n equals 3, the 2nd energy level, there would have been 8, correct? Or n equals 2, I mean. If n equals 2 or the 2nd energy level,
N equals 2.
then it would be 8.
So do you need to have 3rd principal energy level and n equals 3, or could you just know by one of those?
By one of them.
Okay.
They mean the same thing. Okay, what about the next one? What do we got? A ground state chromium atom has how many unpaired electrons? This is what we just did today. So find chromium. The highest energy level, how I would solve it, the highest energy level is 3D, correct?
It has 5.
3D, and it's 3D4? So we'd have 1, 2, 3, 4. So how many unpaired? There's 4 unpaired.
Yeah, where's Chrome? It's 24. Oh, there it is.
Because you know, because of Aufbau's principle, you have to fill everything up until the highest energy level. So all you have to do is check the highest energy level there. How many electrons in the ground state tellurium atom are in orbitals labeled by L equals 1? So what does L equals 1 mean?
P sublevel.
It's a P sublevel.
Where's the
Tellurium is number 52. So how many electrons are in the P sublevel? We have a 2P, we have 3P, we have 4P, and we have 5P though. We have to add them all together. So 1, 2, 3. The first 2P, 3P, 4P are all filled. So that's 18 plus 19, 20, 21, 22. So the answer would be E.
How do you know L equals 1 means P sublevel?
When L equals 0 is S, 1 is P, 2 is D, and 3 is F.
How do you look at it? I guess that's just something you know.
Right.
Yeah, you have to know that part. Okay. If it would have said, if it would have added in there, and if N equals 3 and L equals 1, then you would just go to 3P. But it says just all the P sublevels. That's it.
I have a question.
Yep.
Okay, so when you go from F back to D,
Yes.
and do the 5D1, do you count the 5D1 again?
No. Okay, make sure, which one did we check? We changed 80 changed to 76, 82 is 78, and 91 is 87. Okay, make sure we get this changed. Your worksheet from Thursday is due tomorrow.